The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. So in this session I'm going to discuss all the questions based on PNC and probability. And as we know that probability is important topics for Z, so we'll cover all the questions from 2010 to 2018 based on PNC and probability. But I should say that there is a myth that many questions based on probability appeared in Z. It is not the case. I have gone through all the papers and I could find hardly one or two questions based on probability in every year. So I'll not suggest that you should spend much time on PNC and probability. Rather, you should do algebra and geometry mainly. These are more important than probability and PNC. Instead of probability, you can do more questions based on trigonometry. If you have not done in CAT, you should do some question based on trigonometry. That is more important, rather probability. But still, we should know the basics and we'll cover all the questions. So let's start with 2010 paper. Now the question says the chance of India winning a cricket match against Australia is 1 by 6. So chance is same as probability that India will win a cricket match against Australia is 1 by 6. So the probability of winning is 1 by 6. So probability of not winning it's 5 by 6. What is the minimum number of matches India should play against Australia so that there is a fair chance? Now again, fair chance of winning at least one match. Here the meaning of fair chance that probability is more than 50%. If probability is more than 50%, it is called a fair chance, right? So now the question becomes the winning at least one match so that the probability of winning at least one match is more than 50%. That is the question. So let's say India played n matches. If India played n matches and the question says what is the probability there is a fair chance that India will win at least one match. So out of n matches, at least one match, or at least two matches, or n matches out of n matches, the complete probability should be more than half. That is the question actually. So rather doing this way, if India do not win any of the match, and if this probability is less than half, then the probability of winning at least one match will be more than half. That part is clear. If India do not win any of the match and its probability is less than half, if this probability is less than half, this probability will be more than half. So India do not win a match. Not winning a match, the probability is 5 by 6. So 5 by 6 for not winning first match, 5 by 6 for not winning second match, 5 by 6 for not winning third match, 5 by 6 for not winning any of the match. And that probability should be less than half. So the question says 5 by 6 raised to power n should be less than half. That is the question actually. So if I choose the option, let's say n is 3. So if I take n is 3, it comes out to be 125 upon 216. But 125 upon 216 is more than half. So India cannot say there is a fair chance after playing only 3 matches. If I take 4, then it comes out to be 5 raised to power 4, which is 625, and 6 raised to power 4, which is 1296. Is it less than half? Yes, it is less than half, because if it is half, it should be 1250. It is less than half. So once India played 4 matches, then the winning of at least one match will be more than half. So answer is at least 4. Okay, option B is the correct answer. So rather doing this way, we'll do like this. Clear? And next time you will remember fair chance means the probability is more than 50%. Come to the next one. This is based on PNC. It's not probability, it's PNC. In a locality, there are 10 houses in a row. 10 houses in a row. On a particular night, a thief planned to steal from 3 houses. Let's say I select any 3 houses. In how many ways can he plan such that no two of them are next to each other? Now, the similar kind of question, if you have done PNC during CAT, you should have done it. This is based on distribution. And in distribution, you need to know the two formulas. One is whole number solution and other is natural number solution. Whole number solution says it is n plus r minus 1 c r minus 1. where n is number of things we need to distribute, r is number of places we need to distribute. And the second thing is natural number solution. Natural number solution says n minus 1 cr minus 1. What is the major difference? The major difference is we use the natural number solution when we can assign at least one thing, because in natural number we cannot take 0, but whole number we can use when we can assign 0 things. So let's look the solution now. I select any of the 3 houses. Out of 10 we selected 3. So before this there can be a number of houses. Between these two there can be b number of houses. Between these two there can be c number of houses, and here there can be d number of houses. And can I say the total remaining houses a plus b plus c plus d should be 7? Because there are 10, we have selected 3, so remaining houses are 7. Now, is it necessary that there should be certain number of houses towards this left side? That may be the first house. No condition is contradicting. There may not be any house to the left side. But look at B. Between these two houses, there should be at least one house. I cannot take 0. If I take 0, then these two houses will be next to each other. But it is given that no two houses should be next to each other. So there should be at least one house between these two, and there should be at least one house between these two. So what I'll do, I'll replace B with 1 plus something. There should be at least one house. 1 plus something house. Similarly, I'll replace C with 1 plus Y. D and A can be 0 because that can be the last house, that can be the first house. Here, no house may be there. So A and D can be 0, but B and C cannot be 0. So now the question becomes A plus X plus Y plus D, it's 5. And now A can be 0, X can be 0, Y can be 0, and D can be 0. So we need to use the whole number solution. Whole number solution says N plus R minus 1 CR minus 1. So that is 8C3, and 8C3 is nothing, it is 56. So in how many ways he can steal from these houses? Answer is 56. So I'm sure this is nothing new. If you have done PNC earlier, that is the commonly asked question like this. No two houses should be consecutive. So there should be at least one house. There should be at least one house. There may not be any house. There may not be any house. So A and D can be 0, but B and C should be at least 1. So we replace with at least 1 and then get the solution. Done? Next one. Next one says the scheduling officer for a local police department is trying to schedule additional patrol units in each of the two neighborhoods, southern and northern. That is a southern region, that is a northern region. She knows that on any given day the probabilities of major crimes and minor crimes being committed in northern neighborhood were 0.418 and 0.612, and that the corresponding probabilities in the southern neighborhood were 0.355 and 0.520. Assuming that all the crimes occur independent of each other, and likewise that crime in two neighborhoods are independent of each other, they are independent of each other. What is the probability that no crime of either type is committed in either neighborhood? So if the probability of happening a crime is 418, what is the probability that crime will not happen? We'll subtract it from 1. So that is the probability of northern region. So I'll subtract 1 minus 0.418, that crime did not happen in the major crime did not happen, not minor crime has been happened. So northern region, no crime has happened. Similarly in south, no crime has happened, so I'll subtract from 1. And because all the events are independent of each other, so the total probability that none of the crime has happened becomes 0.645 into 0.480 into 0.582, and that is 0.388. So if you multiply all the numbers, you will end up getting this answer. The answer is 0.069. That is the answer. Option B, A is the correct answer. Okay, so simple question. So just multiply with the probability of crime did not happen in any of the locality, neither major nor minor. Next one. That was a good question. There are four machines in a factory at exactly 8 p.m. When the mechanic is about to leave the factory, he is informed that two of the four machines are not working. There are four machines, M1, M2, M3, and M. Two of them are not working. The mechanic is in a hurry and decides that he will identify the two faulty machines before going home and repair them next morning. So he need to just identify. It takes him 20 minutes to walk to the bus stop. The last bus leaves at 8:32. So he needs to catch that bus, 8:32 bus, and it takes 20 minutes to reach here. So basically he needs to leave the factory by 8:12. If he needs to leave the factory by 8:12, then only he can take the last bus. So right now it is 8. He needs to leave the factory at 8:12. So how much time he has? He has only 12 minutes. If it takes 6 minutes to identify whether a machine is defective or not, and if he decides to check the machine at random, what is the probability that the mechanic will be able to catch the last bus? So if he is able to catch the last bus, he should leave at max at 8:12. Right now it is 8, he needs to leave at 8:12, so he has 12 minutes with him. And how much time it takes to identify? He takes 6 minutes. It is given that it takes 6 minutes to identify that whether the machine is faulty or it is working. So if he has 12 minutes, he can just check two of the machine. So in how many ways he can check two of the machine? He can check any two. So total cases are 4C2, which is 6. Total ways of selecting any two machine out of four machine is 6 ways. So that becomes the total case. What is the favorable case? Now favorable case is if he select two machines and either two of them are faulty. If two of them are faulty, then he can definitely say that yes, these two are faulty. But one more case is favorable. Which other case is favorable? When two of the machine he selects and both of them are working. If these two are working, then he can say the next two are faulty. These are the only two favorable cases. If he selects one working and one faulty, then he cannot say that the next one which is faulty. So he cannot identify the two faulty in this case, but he can identify the two faulty in the first case as well as in the second case as well. So favorable case are 2 and total cases are 6. So what is the probability that he will be able to identify those two faulty machines? 1 by 3. That is the answer. Right now it seems simple. It is actually not. It doesn't click like that. So favorable cases are 2 out of 6 cases. So answer is 1 by 3. That is a good question. Come to the next one. Next question is 6 playing cards are laying faces down on a table. 2 of them are kings and rest 4 we do not know. Two cards are drawn at random. Let A denote the probability that at least one of the card being drawn is a king, and B denotes the probability of not drawing a king. So out of 6 cards, we need to select 2 cards. And what is the probability that at least one card is king? So what I do, if I subtract 1 minus none of the card is king. 1 minus none of the card is king means I'm getting the probability that at least one card is a king, which is equal to A. So what is A? When 2 cards selected and none of the card is king, it means he selected those 2 cards from out of these 4 cards. So 4C2 are favorable cases and total cases are 6C2. So 1 minus that is 6 upon 15. So that is 9 upon 15 is the value of A. Let it be like this. And what is the probability? B. B denotes the probability of not drawing a king. Not drawing a king is this. We have already find it out. 4C2 upon 6C2. That is 6 by 15. So that is 6 by 15 and that is 9 by 15. So what is the answer? Answer is A by B. What is A by B? A by B is nothing else 9 by 15 upon 6 by 15. Answer comes out to be 9 by 6, which is 1.5. So which option will satisfy? The answer is more than 1.25. That is the answer. So it is simple. At least one card is king. Rather doing like this, we can directly say that 1 minus none of the card is king. So the probability comes out to be that at least one of the card is king. Otherwise, we have to make two cases. One of the card is king and two of the card is king. That is also correct. But here we have to just subtract one of the cases to get the answer. Come to the next one. As I always say, first you should try all the question by your own. If you're not able to solve it, then only look for the solution. So first check the question, give a pause, solve it yourself. If you're not able to solve it, then play it. Now the question says the probability that a randomly chosen positive integer, positive divisor of 10 raised to power 29. Now can you tell me how many positive divisor are there? This question is mixed with numbers. So I'm sure you know how to find the positive divisor. If you factorize 10 raised to power 29, it is 2 raised to power 29 to 5 raised to power 29. And for finding the divisor, we multiply the powers by after adding 1 in the power, because we take 2 raised to power 0 also into picture. So how many choices? 30 choices. How many choices? 30 choices. So total 900 divisor are there. So we are selecting any one of the divisor out of this 900 divisors. So total cases are 900. We need to select one of the divisor out of this 900 divisors. So total are 900 cases. What are favorable cases? Now it is saying favorable cases that divisor should be a multiple of 10 raised to power 23. So multiple of 10 raised to power 23 means if 10 raised to power 23 is 2 raised to power 23 into 5 raised to power 23, then what does that mean by multiple? It means the power of 2 should be 2 raised to power 23, or the power of 2 can be 2 raised to power 24. The power should be more than 2 raised to power 23. All are multiple of 2 raised to power 23. The maximum power can be till 2 raised to power 29. Similarly, the power of 5 should also be multiple of 23. You cannot say 23 and then 46. 24 is also multiple of 23. Na? Similarly, it can be till 25 raised to power 29. So how many choices? Till 23 to 29. How many choices are there? 7. Similarly, how many choices are there? 7. So favorable factors are 49. So favorable are 49 and total are 900. So what is the answer? Answer is 49 upon 900, which is in the form of a square upon b square. So that is 7 square upon 30 square. So 7 square upon 30 square, that is, so a comes out to be 7 and b comes out to be 30. What is the question? The question is, what is b minus a? What is b minus a? The value of b minus a is nothing, it is 23. That is the answer. Got the logic? So power of 2 can be any 23 till 29, and with each power of 2 there can be 7 choices of 5. So with this power there can be 7 multiple, with this power there can be 7 multiple. So total how many such factors? There can be 49 such factors which are multiple of 2 raised to power 23. So 49 is favorable, 900 is total. So a square upon b square is 7 square upon 30 square. Answer is 23. Come to the next one. This is a difficult question. Aditya has a total of 18 red and blue marbles in 2 bags. So that is the first bags, that is the second bags. Total 18 marbles he has. Each bag has marble of both the colors. So there has to be both the marbles, red also and blue also. At least one of red and blue. A marble is randomly drawn from the first bag and followed by another randomly drawn from the second bag. The probability of both being red is 5 by 16. So probability of getting a red from here and probability of get red from here, the total probability is 5 by 16. That is the question. What is the probability of both the marble being blue? So can you say okay, if there are x marble here total, there has to be 18 minus x marbles here? and there are, let's say, R1 red marbles and R2 red marbles here. So what is the probability of getting both red? You will say R1 upon X into R2 upon 18 minus X. R1 C1, so R1, R2 C1, that is R2, and X C1 X, or 18 minus X C1, that is 18 minus X. If you multiply these two, this should come 5 by 16. That is the question. Question is clear. Now, what we need to do now, rather making it equation, break x and 18 minus x in such a manner so that the denominator comes out to be 16 or multiple of 16. If it comes out to be 10 by 32, then also I can write it 5 by 16 now. If it comes out to be 15 by 48, then also I can write it 5 by 16. So this product can be either 16 or 32 or 48 or any multiple of 16. So let's check what are the possibility. If this is 1, can I take 1? No, I cannot take 1 because at least one marbles of both the colors should be there. So I can take at least 2. So if I take 2, this will be 16. 18 minus 2 is 16. So product is coming out to be 32, which is valid. If I take 3, now here, assume, if I take 3, this will be 15. And if both are odd, this will be odd. An odd number cannot be multiple of 16. So we'll not need not to check odd, we'll just check the even numbers. So I'll check 2. If I take 4, this will be 14. That is 56, which is not a multiple of 16. If I take 6, this will be 12. That is 72. Again, 72 is not a multiple of 16, so this is not valid. If I take 8, this will be 10, which is 80. 80 is a multiple of 16, so valid. And after that, I need not to check because these cases are going to be repeated. This will be 10 and this will be 8. Answer is not going to change. So only two cases are possible when there are two marbles and there are 16 marbles in one bag. And the second possibility, there are 8 marbles and 10 marbles. So now let's check both the cases. If there are two marbles, it means one thing is very sure that both of them should be 1 1 each. No other possibility because both the colors should be there. So I cannot take 2 0. I have to take one red and one blue. So if there are two marbles, can I say red marbles will be 1? So what is the probability of getting red? It is 1 by 2. And there are total 16 marbles. And if we are taking 32 in the denominator, look at here. If I'm taking 32 in the denominator, so that should be 10. So the numerator product should be 10. So here, if it is 1, that should be 10. It means there are 10 red marbles and 6 blue marbles. Total are 16 marbles. That is the first case. I'm sure you're getting 1 by 2 is getting the probability of red from here, and 10 by 16 is the probability of getting red from the second bag. If I multiply, this comes out to be 10 by 32, which is 5 by 16. Well case. Now look at the second case. If I'm taking 80 in the denominator, which is 5 times of 16, so I have to take 25 in the numerator, 5 times of numerator. So 25 by 80 is again 5 by 16. Now 25 we can get it only one way, guys. 25 in the numerator I can get it, that is 5 into 5. 1 into 25 is not possible because number of marbles are 8 and 10. So here it is 8, here it is 10. So the second case, that red marbles are 5 and total marbles are 8. So blue marbles are 3. And here it is red marbles are 5, total marbles are 10. So blue is also 5. That is second case. That is the second case, and that was the first case. So two cases. Now the question says what is the probability that both the marbles are blue? So what is the probability of getting a blue? 1 by 2 if I take the first case, and 6 by 16. What is the answer I'm getting? I'm getting 3 by 16 in the first case. Look at the second case. Second case is 3 by 8 into 5 by 10. What is the answer? That is 1 by 2. Again comes out to be 3 by 16. So take any of the case, the probability of getting a blue ball, blue marbles is nothing, it is 3 by 16. That is the answer. So that was a difficult question. You have to process in such a manner so that the denominator comes out to be multiple of 16. So two cases, 32 and 80. Took both the cases. From both the cases, answer is coming out to be 3 by 16. Clear? Come to the next one. This is easy. Ramesh plans to order a birthday gift for his friend from an online retailer. However, the birthday coincides with the festival season during which there is a huge demand for buying online goods and hence deliveries are often delayed. He estimates the probability of receiving the gift in time from retailer this. That is the probability of receiving the gift on time. Playing safe, he orders from all the four retailers. What would be the probability that his friend would receive the gift? So what I do, if I subtract from 1 that he will not receive the gift from any of the retailer, he will not receive from here, he will not receive from here, he will not receive from here, he will not receive from here. So if I multiply this, I'll get the probability that he will not receive in any of the case. But if I subtract from 1, I'll get the probability that he will receive the gift from at least one of them. Okay. So he will not receive the gift from here, it is zero point 0.4. He will not receive the gift from here is zero point 0.2. He will not receive the gift from here is zero point 0.1. And he will not receive the gift from here, it is 0.5. So if I subtract this multiplication, what I'll get? 4 into 2 is 8, 8 into 5 is 40, and there are 4 decimals. So I'll put 2 zeros against it to make it 4 decimal. So 1 minus 0.004 comes out to be 0.996. So that is the answer. That is the answer that he will receive the product on time from at least one of the retailer. So 1 minus, he will not receive from the first one, he will not receive from the second one, he will not receive from the third one, he will not receive from the fourth one. So he will receive from at least one of the four retailers. That was easy. Come to the next one. That was a good question again. That is based on area. That is called area based question. A coin of radius 3 centimeters is randomly dropped on a square floor full of square shaped tiles of side 10 centimeter. That is a square tile I'm taking. That is a 10 centimeter each. So what is the area of this square tile? That is 100. And then comes your total cases, total area. The coin is dropped over this. What is the probability that the coin will land completely within a tile? So coin should not touch, should not cross the edge of any of the tile. It should not flip like this. That is an invalid case. So how to get the answer? Now the maximum to maximum coin can fall like this. It should not cross the edge, so it can maximum to maximum fall like this. What is the radius? Radius is 3. So what we need to do, we need to find the favorable area where it can land. So I need to leave 3 from this side. Similarly, I need to leave 3 from this side. This corner and this upper edge. Similarly, it can fall like this. So we need to leave 3 from here and 3 from here. And we are taking the picture into consideration all the 4 corners. So 3 from here and 3 from here. So what is that favorable area? The favorable area, the center should lie in this range. That is my favorable area. If center is lying at any of this given area, it cannot touch the edge. So that is my favorable area. So out of 10, we need to leave 3 here and 3 here. So 6 we left it. So 4 is my favorable side. And similarly 3 left this side and 3 left this side. So 4 is left out. And this is the favorable area. If coin land any of this area, it cannot go beyond the required area. So the favorable area is 16 and total area is 100. So what is the answer? Answer is 0.16. That is the probability. So now it seems simple. It is not. You need to first understand what it is saying. So the question is basically based on area based question. Clear now? Come to the next one. There is again an easy question. A dice is rolled twice. What is the probability that the number in the second roll will be higher than that in the first roll? First, you need to understand that there are 3 possibilities. The first number can be higher than the second number. first number can be equal to second number, and first number can be smaller than the second number. Three possibility. But let's say if I ignore this possibility, then I can say there are half of the chances then first number will be more than the second number, and half of the chances when first number will be less than the second number. So now how to do it? Now the first number on dice can be any number, doesn't matter. Let's say first number is any number. So what is the probability of getting any number? Is 6 by 6. What is the probability that second number is not same? So I'm ignoring this case. What is the probability that second number is not same? Can I say it is 5 by 6? First number can be any number. Second number is not same. So except first number, 5 cases, total 6 cases. So what is that probability? That is the probability that both the numbers are distinct. Both the numbers are distinct. That is the probability we get it. Now, in this probability, half of the cases will be here when first number will be greater than the second number. In half of the cases, first number will be less than the second number. So what we need to find out? We need to find out the probability when second roll will be higher than the first roll. So the required probability is half of this probability. So what is the answer? Answer is 5 by 12. Can you see 5 by 12 quickly? No. So one mind says that we should mark none of this. But look at the options closely. That is 5 by 36. That is 8 by 36. If I simplify this, that comes out to be 2 by 9. This is not 5 by 12. But if you see this option carefully, this option comes out to be 5 by 12. So do not mark answer none of the above. The correct answer is option 3. So sometime it happens that the options are not given in the simplified form. Okay, so correct answer is 5 by 12. Done. So I have discussed all the question guys from 2010 to 2012, 2018. So you can notice that the questions are not many. There are hardly 10 questions in these 9 years. All the questions, including PNC, including probability. Okay, so as I suggested earlier, do not spend much time on this topic. Spend much time on algebra and geometry and trigonometry. In the next session, I'm going to take it trigonometry. So follow my next video and subscribe to this channel if you have not done it till now. Okay, thank you.